Hey, good morning, everybody. We are diving into, we're not just getting into Chapter 8, because you might notice that the first assignment in Chapter 8 is actually 8.1.4. Okay, so we're getting into that. Hopefully, you did well on your Chapter 7 test. If not, you're asking your teacher, hey, can I retake that? Or can you show me what I did wrong? But we're digging into Chapter 8. And Chapter 8 has something that we're going to start with called a Box and Whisker Plot. Okay. All right. So Box and Whisker Plot, if you know how to get the median of a group of numbers, the Box and Whisker Plot, all you're doing is getting the median twice, or three times actually, and then you're getting the greatest and least number. And that's shown in a Box and Whisker Plot. It's a pretty cool way, once you understand how they work, to really get a good picture of what all those numbers represent and where they are distributed. Okay, so first off, I don't know if you hear in the background, we got some Dave Brubeck playing, right? Dave Brubeck Quartet, and this is from the famous album that has the song Take 5. So I think you guys should have that in the background while we do. But let's get busy, because this is a long homework assignment, right? There are a lot of problems on this one. So this first one, I'm just going to show you how Box and Whisker Plot works. So we're going to do this together. You need basically 5 numbers to make your Box and Whisker Plot, right? You take all the numbers and you put them in order, okay? And you get the least, okay? And the least number, when you put it on a number line, is the left end of your whiskers. Okay, this is a box, this is a whisker. Sorry about that line, I made a mistake. Okay, and you can see it here. This is the left whisker here, this is the right whisker, and there's the box. Okay, so you need the least number, you need the greatest number, that goes on the far right. Okay, so you can see in this group of numbers, the least number is a 0. The biggest number looks like that's 150, so it looks like it's 160. Okay, so that's 0. That's 160. You need the median. And remember what the median is. That's after putting all the numbers in order from least to greatest or greatest to least. It's the middle number. Okay. And that's going to be the line that goes to the center of your box. So that's 100, 110, 120 is the median. And remember what the median means. If it's the middle number, then how many numbers are bigger than it? And how many of the numbers are smaller than it? Well, should be half the numbers are bigger and half the numbers are smaller, right? Right? So if you have 11 numbers and you get that median, well, 5 numbers will be bigger and 5 numbers will be smaller, right? Okay, so that's how the median works. Now, if you think about the median, and because half the numbers are smaller, what if I were to get the median of that bottom half? Right? I just cut off all the numbers above the median, and now all the numbers I have left are here. Get the median of that group of numbers, and that's the left edge of the box. So this number here, that's like the median of the bottom half. Now I go back and I do the same thing. Take the median, take the biggest number, take all the numbers in between, and get the median of all of those numbers. That's the right side of the box. Okay, so the median of the upper half, that's right there. That looks like it's 140. The median of the lower half, that's right there on 100. And then the cool thing about a Box and Whisker plot is you have 25% or 1/4 of the numbers are between the left whisker and the left side of the box. You have 1/4 of the numbers between the right whisker and the biggest number. You have half the numbers inside the box, and within that box, 1/4 of the total numbers, right? Half of the middle numbers are on the left side of the box, left side of the medium, inside the box, and 1/4. So it splits all of your numbers into 25%, 25%, 25%, and 25. Okay, and they call each 25%, they call it a quartile. You know how a quarter is a 25% of a dollar? Okay, a quartile is 1/4 of all the numbers. Okay, so it's kind of cool to see. You can just immediately glance at Box and Whisker Plot and really say, okay, well, the median's here, right? The median's here, but I got a lot of numbers clustered in the middle there, just between 100 and 140. Half the numbers are inside there. It goes spread out right here, but this is just 1/4 of the numbers, just like this is 1/4 of the numbers. So these are more spread out, and these are more tightly packed. Okay. Pretty cool way to look at these things. So in that first question, it says, how do you think Alden collected the data for his box plot? Now, this is calories and sodas. That doesn't have much to do with the Box and Whisker Plot at all. You know, how would you, if you were going to get how many calories are in each can of soda and get a whole bunch of different brands and stuff, how would you get it? That data? Well, you can look it up online. You can Google it. You can look at the side of a can, right? The side of the can has the nutritional information. It'll always tell you how many calories are in it, right? Per serving and all that kind of stuff. How much protein. And I got to tell you right now, there's no protein in a soda, right? Unless they had it. How much sugar, you know, the ingredients, stuff like that, carbohydrates and fat. Okay, so yeah, that's a question. You know, what do you think? Yeah, there's no right answer. There's a lot of possible answers. Now, in this, the B, it says, according to this graph, give a complete description about the calories of the 11 brands of soda as you can. Consider the center, shape, spread, and outliers. Okay, so this 0 might be an outlier. It might be like one soda had 0 calories or something like that. It's a diet soda or something. But you could say all, you know, the least amount of calories in one of the sodas is 0. The greatest is 160. Most sodas, you can say, right, have more than 100 calories, right? And the median average is 120. And half of all the sodas that you listed have calories between 100 and 140. Okay. So all sorts of things you could say about that, but that's how a Box and Whisker Plot works. If you have to rewind this part of the warm-up and watch it again, warm-up assignment and watch it again, you might, because on this next set of Box and Whisker Plots, I'm kind of going to let you try to figure that out yourself. This has to do with the age of kids in 3 different schools. Okay. But again, come back to this. These are the 5 things that you can quickly see represented in a Box and Whisker Plot. The least is the left dot, right? That point, that's the smallest number on the all of the greatest is all the way on the right. The median is the middle of the box. The median of the upper half is the right side of the box, outside, and the median of the lower half. So again, you got 25% of the numbers between here and here, 25 between here and here, 25% between here and here, and 25%. Okay, so it divides it up into 4 different areas of numbers, and you can see where they're concentrated and see where they're spread out. Okay, all right, here we go. Let's go forward. These order of operations problems. Remember, the first thing I'm going to do is parentheses. I'm going to do that 4 plus 8 is 12. And now I have 12 divided by 12 plus 2 3/4. Well, 12 divided by 12 is easy. I'm going to divide before I add. I'm not doing this because it's lined up first. I'm doing this because I have to multiply and divide before I add and subtract. So I end up with 1 plus 2 3/4. I'm going to let you finish that problem. All right, this one I have parentheses again. 8 minus 5 is 3. So I got 3 times 3 plus 6 plus 2 times 7. Now, of what's left, got to multiply here and multiply here. The last thing I'm going to do is this plus and plus. Okay, so find the product of 3 and 3, the product of 2 and 7. Put that answer there, and then you just adding 3 numbers. Okay, we'll let you finish that. Again, parentheses, 3 and 1300ths, 2 and 1200ths, When I add those, I get 5 and 2,500. So that parentheses is done. Here I have 49 divided by 7 times 5 plus 4 times this. So I'm going to do this division first. I get my answer, and then I'm going to multiply and then multiply. Last thing I do is that addition. I'm going to let you finish that. And this next one, I have 8-53. I had Maciel, I guess, and Alejandro were trying to figure out the answer to 8 and 4200s plus 3/10. Okay. And Maciel thinks the answer is 8.72. Okay, but Alejandro thinks the answer is 8.45. I'm going to remind you to ask yourself, what's the number one rule when you add or subtract decimals? And I'm going to have you do that. And I'm guessing the person that got the wrong answer, one of these is wrong, one of these is right, didn't follow that rule. So I'm going to have you check that. Okay? All right, we have to figure out the area of this. Now, I made it easy for you with this box, all this graph paper. This is 6 boxes, right? 6 squares. This is 18 squares. So I added, you can actually count these squares if you want. But if you're going to get the areas, I probably wouldn't do that. I'm probably going to do this. Draw a line there and figure out what's the area of this rectangle. 18 times 6. Okay? And then I'm going to draw a line here. I'm going to say, what is the area of this rectangle? That's 9 times 9. Looks like a special rectangle, a square. And then I'm going to have you figure out the area of this rectangle. The hard part about this is you have to use some logic to figure out what are the dimensions. I don't have any of these numbers. I know that this is 24, and this part of it's 6, and this part of it's 9. So what's left? Okay. 6 plus 9 is 15. The whole thing is 24. What's left is 24 minus 15. It's going to be how long this is. How tall is it? Well, this is 18, and this is 15. So what's this? Okay. And then I'm going to get this area, and this area, and add them. Okay. I'm going to let you try it. All right. On to 8-55. We have these problems. It says, use the distributive property to rewrite each expression below, and then evaluate each expression for y equals 3 and z equals 4. Now, they use the distributive property to rewrite each of these. I say we're going frontwards on some of these and backwards on others. Okay. When I learned the distributive property, it was all about this. When you had a number outside parentheses, and you were going to multiply that number by each number inside the parentheses. So I'm going 3 times 4 minus 3 times 2z. Sorry, 3 times 4. 3 times 8 minus 3 times 2z. So 3 times 8 minus 3 times 2z. The number one mistake that people make when they do this is they do the multiply the first two numbers, and then they just subtract what's left. You don't want to do that. You multiply, you subtract this times that. Remember, everything inside. So 3 times 8 is 24 minus 6 times z. Okay. Now on these three, you're working what I consider backwards on distributive property, and that's when you're what's called factoring. You're looking for a number or something that goes into both terms. Is there something that goes into 2y squared and 5y? Yeah. Why? Okay. Is there something that goes into 5z squared minus 15z? Yeah, there's actually two things in that one. Okay. There's a 5, because 5 goes into 5 and 15, and a z, because z goes into z squared and z. And on this one, this is kind of tricky. The only thing I can find that goes into both these is 2. 2 goes into 4, and 2 goes into 6. Okay, so you're going to pull those out and sort of go backwards. Okay, and then go substitute. Okay, All right, what do I mean by going backwards? If a 2 goes into both of these, and I'm going to say this is the same as 2 times. 2 times what is 4y? 2y. And 2 times what is 6z? 3z. Okay? So it's kind of going backwards is what I consider. Okay? I'm going to have you try those. Okay? Come back tomorrow and check your answers. Okay? I'll help you on this one too. You're still going to have to go substitute. I'm going to pull a y out of both of these terms. Okay? It's kind of like simplifying fractions. You find something that goes into the top and the bottom. We'll find something that goes in both terms. Y goes into 2y. How many? 2y squared? 2y. Okay, because y times 2y is going to be 2y squared. Y goes to 5y. How many times? 5 times. So y times 2y minus 5 is the same as this. Okay? And again, you're going to go substitute when you get done. They want to find out what is the answer if y equals 3. Okay. All right. This next set, we have school A, school B, and school C. What is the youngest kid that goes to school A? Well, all that data, the farthest to the left, I got a kid at school A who's 5 years old. What's the oldest kid that goes to school A? I got a kid at school A that's 14 years old. What's the median age for a kid that goes to school A? Remember, that's the middle of the box, 8. Okay. What is the inner quartile on the left? Okay. So this 25%. So half of the kids are younger than 8. Half the kids are older. Of the half of the kids that are younger than 8, what's the median of that group? Well, that's 6. Okay. What's the median of the upper half? Okay. Well, that's 9. So half kids are between 6 and 9 at this school. Okay. So you're going to look at that and try to answer those 5 questions being asked right here. Okay. And I got to tell you, sometimes they throw a question in there that you can't answer. Hint, hint. Okay. Hint, hint. Excuse all right. Got it? Okay. Let's go on to the next one. Complete the following division problems. Okay. And we are dividing fractions, dividing decimals, and dividing mixed numbers, right? So first thing I do on these is I use the C method to turn these into fractions. 3 times 5 is 15, plus 2 is 17 thirds. 5 times 1 is 5, plus 1 is 6 fifths. And then follow Miss Nord's advice, smell my feet. That first one the same, multiply instead of divide, because multiply fractions is easy. And then flip that second number. Okay. Now on this one, who are you watching out for? The math police. If you start dividing with this decimal outside the box, you will hear this. And that siren is ruining Dave Brubeck's sound in the background, right? All right. So you got to get rid of it. Remember how you get rid of it? You got to move it over 2 spots. And if I move it over 2 spots outside the box, what do I also have to do? Hopefully you're saying move it over 2 spots inside the box. And now's when I asked someone in the class, I said, raise your hand if you're smart. And then I find a kid who didn't raise their hand because they weren't paying attention. And then I say, Bobby, if you were smart, what would you do right here? All right. And what do I say about this? Don't divide with 4 scoops and 4 decimals. You know what your problem is now. Rewrite your problem. It takes about 5 seconds. Why don't you time me? Okay. Boom. Now I divide. Okay. All right. Go for that. And on this one, you're going to do the same thing as you did with the first one. Use the C method. And then smell my feet. Okay. All right. What are the next 3 numbers? I got 1, 3, 7, 13, 21. What's happening next? And next, and next, and then describe that pattern in words. Okay. You want a hint? If you don't want a hint, plug your ears. If you want a hint, figure out the difference between those two and the difference between those two. and the difference between those two, and the difference between those two. Okay, that's my hint for you. All right, 859, we're finding the prime factorization of all of these numbers, and then we're going to look at each pair and find the greatest common factor and least common multiple. Prime factorization of 3. 3 is prime. I'm going to circle it. It's not a factor tree, it's factor seed. But 24, I can say that's 3 times 8, right? 8 is the same as 2 times 4. Remember, I circled the prime numbers. So the prime factorization of 24, remember, I got to put them in order. 2 times 2 times 2 times 3. You can rewrite that 2 to the third power times 3 if you want. Now, what is the greatest common factor of 24 and 3? Which one's common? 3, right? What is a least common multiple? Okay, well, going to be 24, right? Okay, so you're gonna do those. Greatest common factor, that's the biggest number that fits into 3 and 24. And the least common multiple, that's the smallest number that's a multiple of both. Okay, can I get a smaller multiple of 24 than 24 times 1? No, okay. And this is what's confusing sometimes. Whenever the small number fits into the big number, then the smallest number is going to be your greatest common factor. And the bigger number is going to be your least common multiple. People have trouble. The smallest number is the greatest factor, and the biggest number is the least multiple. Okay. All right. That's prime. Prime factorization of 9 is 3 times 3. Okay. What is the greatest common factor? Well, the only number that goes into both these is uno, right? And what's the least common multiple? Let you figure that out, and let you figure out these last two. Okay. All right. Last question is one of those ones where, you guys see that? It's just kind of important to know how to do this. Okay. So we're talking about distributive property, and we're also talking about evaluate for the value given. Okay. And remember, when it says evaluate an expression for the value given, I want you to translate that into, all you got to do is give a substitute. All right. They want you to know, what does this value if y equals 2? Y equals 3. 6 times 3 to the second power. That's all you got to do. What is the value of this if I substitute x equals 1/2? So I got 4 times 1/2 plus, and y equals 3, 5 times 3. That's all you got to do. On these, remember, on these top two, you're going to go distribute 3 times 2 plus 3 times x. You're going to distribute 2 times x plus 2 times 2y. And then when you get done, they're going to want to put all the x's together, put all the y's together. Okay. Here you're doing the opposite. You're factoring what goes into 5x and goes into 10. Hopefully you recognize that's a 5. I'm going to let you figure out what goes in there. What goes into both 24 and 18y? That's going to be a 6. I'm going to let you finish. All right. Sorry for such a long assignment, but that first part, I wanted to teach you how the box and whisker plots work, because I think they're pretty cool. All right. Have a great Aloha Thursday. We will see you mañana.